All right, I'm going to make this little video just to kind of go over a couple of these problems and just work a few as examples. Some of the ones that you don't have to do that weren't assigned to you. We're going to work those as examples so you'll know how to do the other ones. So on mole calculations, molecular mass and mole calculations, molecular weight and mole calculations, I believe you had to do on that one, you had to do the odds. So let's take this as our example. I think this would be a good example to do. So with these, all you're going to do for the molecular weight is you're simply going to look up the weight of each element, multiply by how many there are, and then add them all together. So SB is antimony, so you will look in your periodic table and find the atomic mass of antimony, which is SB, and that is 121.8. So sorry, 121.8. And we're going to add to that the mass of 3 nitrogens. Now I have 3 nitrogens because of this subscript out here. I have 3 nitrates. So that means I have 3 nitrogens. So that's going to be 3 times 14. So I have 1 antimony. So I have 3 nitrogens. So that's 14 times 3. And then I have 9 oxygens because 3 times 3 is 9. Okay. So I'm going to multiply those things out and then I'm going to add them all up together. And when I do that, so if I get my calculator, that's 121.8 plus 14.03 times 3 plus 16 times 9. That gives me 307.8 grams. Okay. And so that would be my answer for number 18. And that's showing your work. And that's how you're going to have to show your work for all of those. So like I said, it might be easier for you to work these out on a piece of, to work these out on a piece of paper. All right, let's scroll down and do a couple of these where I give you the name. So if all I give you is the name, then what you're going to have to do is you're going to have to write the formula. And that's what we've been doing back and forth on all of our quizzes and stuff. So this shouldn't be anything new to you at this point. So let's take 26, for example. So we have aluminum. Remember, aluminum has a +3 charge because of where it is on the periodic table. Nitrate is NO3, and it has a -1 charge. So I need to have 3 of them in order to get my charges to balance out. Okay, so now I'm just going to do the same thing I did before. Okay, actually, this turns out to be almost identical. The only thing that's different is the aluminum. So I'm going to have 14 times 3 for my nitrogens. I'm going to have 16 times 10 for my oxygens. I'm going to look up the mass of aluminum on the periodic table, and that is 26.98. And I have 1 of those. So 26.98 times 1. And then I'm just going to add all of those up together. So 26.98 plus 14 times 3 plus 16 times 9 gives me 121 or 112.98. And all of these atomic masses or atomic weights are in grams. Okay, so that's how you'll do those. Do you remember you're only doing the odds? Okay. All right, down here for number Roman numeral 2, again, you're just doing the odds. What we're going to do is we're going to turn moles into grams. Okay, and this we looked at how to do this with our POGL. So you're going to start by just taking what you're given, which is 1 mole of calcium carbonate. And we know that to convert 1 mole of anything, that is its atomic mass. or its molecular mass, molecular weight. Okay, so I'm going to do the same thing. I'm going to add up the mass of calcium and the mass of 2 chlorines. Chlorine is 35 times 2 plus calcium, which is 40. Let me double check and make sure calcium is 40. Yes. So 35 plus 40 is 110. So in 1 mole of calcium chloride, there's 110 grams of calcium chloride. My moles cancel out. I multiply 1 times 110, and that gives me 110 grams of calcium chloride. And this is what you would need to do to show your work for these types of problems as well. Okay. On the ones where you are given the name, you'll have to do the same thing. You'll have to come up with the formula and then work it out accordingly. So this one, potassium iodate would be K is for potassium iodate. Is going to be IO3 for the polyatomic ion. Okay, so I'm going to take 0.25 moles of KiO3 and 1 mole of KiO3. I have to figure out how many grams of KiO3 there are. So I'm going to say 16 times 3 for my oxygens. I know that one by heart. I'm going to look up potassium. Potassium is 39. And iodide is 127. So 16 times 3 is 48 plus 39 plus 127 is 214. My moles cancel out there, and 0.5 times 214, or I'm sorry, not 0.25 times 214 is 53.5 grams of KiO3. Okay. Now, hopefully you are seeing that if you do not get this formula right, you will not get the right answer. Okay, because it's based on the mass of the correct atoms and number of atoms being in that formula. So it's really important that you know how to write formulas and write names. All right. In 3, we're just going back in the opposite direction. We're changing grams to moles. So we're pretty much just going backwards. Okay, so we're going to set up our unit multiplier again. You're going to start with what you were given, but this time instead of moles being on the bottom, grams are going to be on the bottom because we want grams to cancel out. So grams of magnesium fluoride in 1 mole of magnesium fluoride. So I'm going to look up the mass of magnesium and the mass of 2 fluorines, add them together. Magnesium is 24. Fluorine is 19, and there's 2 of them. So 19 times 2 plus the magnesium, which I already forgot what it was, 24. That should be 100. No, should not be 100. Sorry, 19 times 2 plus 24 should be 62. So I have 62.3 grams, and I'm going to divide that by 62 grams, and that's going to give me 1 mole of magnesium fluoride. Okay. Yeah. And again, on these, you'll just give me the formula first and then use the formula to finish out the problem. Okay. And then, like I said, the answers are all back here, so you can look up and make sure you got your answers correct. But with that, I must see your work. If you do not show me your work, you do not get any credit at all. Okay. All right, so let's do percent composition. So with percent composition on these, what we're going to do is we are going to basically find the molecular mass, and then we're going to find, after we know the molecular mass, we are then going to find the percent of each element out of the total. Okay, percent composition would mean the percent of that element out of the total mass of that compound. So for, let's do number 2. For HBr, hydrogen, so I'm going to find my molecular mass first. Hydrogen is going to be 1, and the molecular mass of bromine is 70 or 80. So this is 81. So the molecular mass of this molecule is 81 grams. So to find the percent composition, what I'm going to do, so the percent hydrogen would be equal to 1 gram divided by 81 grams times 100. The percent bromine is going to be equal to 80 grams divided by 81 grams times 100. So 1 divided by 81, that's going to be 1%. And then 80 divided by 81, times 100 is going to be 98.8%. Okay, and obviously both of those, when you add them back together, they should add up to close to, if not 100. They should not be over 100. Okay, and this is going to be a little bit under 100 because I rounded that to 1. It actually was like 1.2. Okay. And then, of course, with the ones where you were given the name, you will have to you'll have to write the formula, and then with these you only had to do, wait a minute, we had to do 1 through 10, we had to do 21 through 25, and then we had to do 41 through 45. Okay, so on these you're given the name and asked to do the same thing. So phosphoric acid, the formula for phosphoric acid is H3PO4. Okay, so you got to get the formula first, and the molecular mass for that would be 31 for the phosphorus plus 16 times 4 for the oxygen plus 1 times 3 for the hydrogen is 98. So to find the percent hydrogen, that would be 3 divided by 98 times 100, and you would need to divide that out and actually find the percent. To find the percent phosphorus, that would be 39 divided by 98 times 100. And to find the percent oxygen, that would be 16 times 4, which is 64, divided by 98 times 100. Okay. Make sure, again, that you divide those completely out and get me an actual number. I'm just leaving that way for time's sake. All right, moving on to 41 through 45. On 41 through 45, I'm going to work 46 as an example of that, where you are asked to find the percentage of one particular element. Okay, so actually these are a little bit easier. So find the percent. I take that back. I'm not going to do 46. going to do 50. Find the percent chromium. And nope, I take that back. I need to find one. Trying to find an easy one to do. That's what I get for trying to find a shortcut. Okay, let's look at 47. Percent carbon in sucrose. So again, what I'm going to do is I'm going to add up, I'm going to find the molecular mass first. So that's going to be 12 times 12 for the carbons, plus 1 times 22 for the hydrogens, plus 11 times 16 for the oxygens, gives me 342. That's my total mass of the entire molecule. I want to know the percent carbon. So percent carbon is going to be 12 times 12 for the carbons, which is 144, divided by 342 times 100. That's 42%. Actually, it's 42.11%. Okay, so you'll do that same thing on 41 through 45. The key for these, again, is to find the molecular weight or molecular mass first. On ones like 43, cupric sulfate, that's copper sulfate, and then the pentahydrate would be 5 waters. So we'll tell you that. This means 5 H2Os. And this is just copper sulfate. Don't worry about the cupric thing. It's just copper sulfate. So that would be Cu. Hang on. Let me make sure we know which copper it is. Okay, so yeah, this is copper 2, copper with a +2 charge. And then, of course, sulfate is SO4. And the rest of these are the rest of these formulas are fairly easy to do. Okay. All right, so that's it. If you have any questions, let me know, and that should take you through both of those worksheets. Have a good day.